Our next element of the interest is sulfur. We'll write here sulfur. Okay, that is the second element of the group 16. So sulfur, allotropes. Allotropes of sulfur. Sulfur exists in these two forms, that is S8. If you heat this compound to 398 Kelvin, okay, you will get the compound which is S6. This is orthorhombic structure, orthorhombic, RHO, orthorhombic, and this is monoclinic structure. Both the structures, okay, this both S8 and S6, okay, both the structures are interconvertible because one form of the sulfur could be converted to the other thing. Okay, so interconvertible. With respect to structures, let's talk about the S8. Sulfur is connected in this way. This is the sulfur. Then sulfur. Okay, this is the thing that is 3, 3, 6, 7, 8 sulfur are there. This is S8 structure. This is called as crown shape. Crown shape. Other S6 is existing in a chair form, means there is a S over here, S, and this is S. Okay, this is a chair form of the sulfur. This is S6, and this is a chair form, chair form, okay, or chair shape, you can say. These are the two structures of the sulfur in which it exists, and both the structures are interconvertible. The next is reactions of the sulfur. How sulfur reacts with the other compounds. Reactions of sulfur. First reaction is sulfur plus NaOH. The oxidation state of the sulfur over here is zero. Okay, so this gives you Na2 minus and the means here this negative charge, negative sign, this is a neutral compound. This negative sign is the oxidation state. Okay, I'll show you the different color. This is a negative, -2 is the oxidation state on the sulfur, and here this is the oxygen state. If you calculate on this sulfur, it will be a +4. Means what is happening from 0, one compound you are getting where the oxidation state of the sulfur is -2, means it is getting reduced, and the other compound where the sulfur is being oxidized. Okay, so such type of reactions are called as a disproportionation reaction. This is disproportionation reaction. Okay, then next is sulfur reacting with H2SO4. This is going to give me a sulfur dioxide. It is a gas, and the water. So what has happened over here? The oxidation state of the sulfur, if you check. See, I always focus more on the oxidation state. Many times in the reaction, I focus on oxidation state because oxidation states tells you about the what reaction is it really oxidizing or reducing nature. It tells about that thing. Means here the oxidation state of a sulfur, if you calculate, then how much it will be? 2 into 1 plus x plus 4 into minus 2, which is equal to 0. So 2 plus x minus 8 is equal to 0 and x is equal to 6. Right here the oxidation state of the sulfur is plus 6 and it is here plus 4. Means here this is a reduction. The reduction of the reaction is taking place. Um, so next is concentrated HNO3, means sulfur reacting. Means here also the oxidation state of a sulfur is 0, right? The oxidation state of the sulfur is 0 and it is changing to plus 4. Like I can show this 0 to plus 4. This could be also oxidation. Okay. Then here, now how I can describe this oxidation? This is a sulfur where the oxidation state is changing to plus 4 and here from plus 4 to plus 3. Uh, if you going to see, then the reduction with respect to this sulfur is happening and the oxidation with respect to this sulfur is happening. We cannot call this to be a specifically a reduction. Here if you see with respect to this sulfur, there is a removal of the oxygens and the hydrogen, right? And with respect to this sulfur, if you are watching, then oxygen is being added to this. Oxygen is being added. So this is a oxidation we can say, and the sulfur is getting reduced. Then a concentrated HNO3 will give you H2SO4, NO2 gas, and H2O. Okay, and if the sulfur is reacting with O2, if sulfur is reacting with O2, what we get is a sulfur dioxide and a sulfur trioxide. Both are gas. This you will get in a 95% and this is just 5 to 10%. Okay, this is oxidation. Now, if I talk about the acidic strength of the sulfur dioxide, which is more acidic, which is more acidic, is it a sulfur dioxide or a sulfur trioxide? The answer is the compound having higher oxidation state. Okay, one which has the higher oxidation state is more acidic. One which has higher oxidation state is more acidic. Means if you compare the sulfur dioxide and a sulfur trioxide, the oxidation state of a sulfur over here is plus 4 and here it is plus 6. Okay, so therefore the sulfur trioxide is more acidic. The acidic strength of the sulfur trioxide will be more. Now, on the basis of oxidation state, why do we conclude that higher the oxidation state, more acidic? See, if you compare the Lewis acid concept, then Lewis acid is the concept where the acids are something which accepts a electron pair, right? So if the positive charge is more, this compound, this sulfur will be in the more in the need of the negative charge, more in the need of the electrons. Comparatively, this will be less need because the positive charge is less. So more higher the oxidation state, higher is the oxidation state, more is the acidic. So more acidic is the sulfur trioxide.